Hello everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation from z equal to e power ay into f of ax plus by by eliminating arbitrary function f. We are given a relation and we are asked to form a partial differential equation by eliminating this f. Let's see. Given z equal to e power ay into f of ax plus by, right? Consider it as some equation number 1. Now let's partially differentiate it with respect to x. Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of 1. Or you can do directly. Since we are partially differentiating with respect to x, so we will treat y as constant here. This gives us dou z by dou x equal to, here you are having a, right? So we will treat it as constant and we will write this as e power ay, constant into derivative, right? Since we have a notation, dou z by dou x equal to p. Let's replace dou z by dou x by p. We'll get p equal to e power ay into partial derivative of f of ax plus by with respect to x. F dash of ax plus by into inner derivative, that is dou by dou x of ax plus by. This gives us p equal to e power ay into f dash of ax plus by into partial derivative of first term plus partial derivative of second term, right? This gives us p equal to e power ay into f dash of ax plus by into, here a is constant, right? We can write this as a into dou by dou x of x plus partial derivative of constant with respect to x is 0. Since we are partially differentiating with respect to x, so we will treat y as constant and also b is a constant, so by is treated as constant here. This gives us p equal to e power ay into f dash of ax plus by into a into partial derivative of x with respect to x is 1, a into 1, which is a. I'll get p equal to e power ay into f dash of ax plus by into a, or p equal to a into e power ay into f dash of ax plus by. Consider it as equation number 2. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Apply dou by dou y on both sides of 1. This gives us dou z by dou y equal to, here we are partially differentiating with respect to y, so we'll treat x as constant, okay? And here you're having e power ay, which is in y, and this is also a function of y, which involves a y, okay? So we'll apply u v whole dash formula, which is u dash v plus v dash u. You can write this as dou by dou y of e power ay into f of ax plus by plus dou by dou y of f of ax plus by into e power ay, okay? Since we have a notation dou z by dou y equal to q. So let's replace it by q. We'll get q equal to partial derivative of e power ay with respect to y is a into e power ay into f of ax plus by, right, plus partial derivative of f of ax plus by with respect to y is f dash of ax plus by into inner derivative, that is dou by dou y of ax plus by into e power ay. This gives us q equal to a into e power ay into f of ax plus by plus f dash of ax plus by into inner derivative dou by dou y of ax plus dou by dou y of by. See here, ax is constant. I wrote as it is up to here. You can write this as partial derivative of a constant with respect to y is 0 plus here b is constant. So we can write this term as b into dou by dou y of y. Okay, into e power ay, which gives us q equal to a into e power ay into f of ax plus by plus f dash of ax plus by into b into derivative of y with respect to y is 1, b into 1 into e power ay, which gives us q equal to a into e power ay f of ax plus by plus b into e power ay into f dash of ax plus by. Fine. Right. Consider it as some equation number 3. Now we are having equation 3, q equal to a e power ay into f of ax plus by plus b into e power ay into f dash of ax plus by. If you notice, we are having f of ax plus by and f dash of ax plus by. So using 1, we can find the value for f of ax plus by, and using 2, we can find the value for f dash of ax plus by. Okay, so let's see. We have 1 z equal to e power ay into f of ax plus by, right? So what I'll do is, I'll bring this e power ay to LHS, or just, fine, it's not necessary to bring this. Just replace e power ay into f dash of ax plus by, that is e power ay into f dash of, sorry, f of ax plus by z. Okay, alright, or okay, or it's okay to take e power ay to RHS, you'll get. Okay, if you want to replace e power ay into f dash of ax plus by directly z, just replace it by z, or if you want to replace only f of ax plus by, then replace f of ax plus by using z by ay. Okay, let it be. From 2, we have 2 p equal to a into e power ay into f dash of ax plus by. So here observe, we having e power ay into f dash of ax plus by, right? So we can just replace e power ay into f dash of ax plus by using p by a. Bring this a to LHS, you'll get p by a equal to e power ay into f dash of ax plus by. Okay, you can just replace, or e power ay into f dash of ax plus by can be replaced by p by a, right? Or if you want to replace e power ay into f dash of ax plus by, you can just use it. Or if you want to just replace f dash of ax plus by, then I'm writing the same equation, right? Just take these two to RHS, will get f dash of ax plus by equal to p by a into e power ay. Okay, fine. Now coming to this, the above equation becomes q equal to a into e power ay into, I'm going to just replace f of ax plus by using z by e power ay. No confusion, right? And here I'm going to replace only f dash of ax plus by using p by a into e power ay, where e power ay gets cancelled and you'll get q equal to az plus b by a into p, which is the required partial differential equation, or you can write this as q equal to az plus pb by a. Okay, right? Fine. Now let's see another way. Or suppose I am replacing e power ay f of ax plus b, then I'll get q equal to this a into, I'll replace e power ax, this term, e power ay into f of ax plus by this z. I'll get az plus b into, I'll replace e power ay into f dash of ax plus by using p by a, which gives us q equal to az plus pb by a, which is the required partial differential equation. Okay, we can compare 1 and 2, I mean the terms of equation 3 with 1 and 2, and you can just replace, or you can just replace only f of ax plus by and only f dash of ax plus by using 2, I mean 1 and 2. Fine, therefore q equal to az plus pb by a is the required partial differential equation. It's p. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.